Hello everyone and welcome back. We are talking about heat transfer in 6.2 and these are your guided notes. What we're going to be looking at is whether or not you can explain how heat is transferred in conduction, convection, and radiation. This is very important for how weather and climate works on our planet. Heat transfer is the energy transferred from a warmer object to a cooler object until it is equal, and that is referred to as heat. And you can see A and B, one is cooler and one is hotter. A is hotter, red, and when the two are put next to each other, they transfer heat until they're both the same temperature. There are three types of heat transfer that we will be discussing. The first one we have is radiation. This is how the sun's energy gets to our planet. 25% of the sun's radiation is reflected by the clouds and particles in our atmosphere. 20% is absorbed by particles in the atmosphere, and 50% reaches and is absorbed by the surface of the planet. 5% is reflected back by the land and sea surface. So out of that 100%, that's the breakdown. Most of it is absorbed by the Earth's surface. Conduction is a direct transfer of energy from one substance to another by touching. And what you can see in the picture above is they are holding a piece of metal and heating it over a candle. And the one part of the metal is getting hot and it's transferring the energy through the piece of metal towards the person's hand. And eventually their hand will feel that heat. Walking on sand or asphalt. If you walk on a hot surface, it will be hot on the bottom of your feet. That is transferring heat directly from the surface into your skin. Solids and some liquids do this, but gases do not. Gases cannot conduct. So solids and liquids can be conductors of heat. Radiation, talked about earlier with the sun, is the direct transfer of energy by electromagnetic waves. So the radiation coming from the sun is coming out as waves of radiation. It's not hot, it's waves. And those waves transfer energy to the atoms and make them move fast. That's how they become hot. So the sun shining on you is an example of you being hit by radiation. Now, not 100% reaches the planet. As we saw earlier, some of it is reflected in the atmosphere, some of it is absorbed in the atmosphere, and some of it is reflected by the surface. Convection is a transfer of energy by movement of a liquid. So as you can see in the pot up in the top right corner, when you're heating water in, say, a pot, you get conduction between the heating surface and the metal. But then the metal hits the water and it heats up the water at the bottom. That water then starts moving upwards because it gets warm. That is a convection current, and it creates a cycle where the hot water rises and the cold water sinks. Molecules in liquids and gases especially can move from place to place and take their heat along with them. This is also something that happens inside some of the newer ovens. They're called convection ovens. They have a cycle of air moving. That hot air circulates through the oven. Ocean currents and boiling water. Ocean currents are another convection source. It can heat at the top, the surface will heat up, and you get these ocean currents going where it mixes the hot and cold water together. Now, convection current is a difference in density that produces motion of currents. So the warmer, less dense will rise. So if it's water, that less dense water will rise, and the cooler will sink. And that's how you get that the mixing of temperatures. The same thing happens with air. You'll notice that the warm air in your house is generally upstairs, and the cooler air will sink downstairs. And you can notice that in a house where the air conditioner's been on. Go upstairs and then walk down a level and then walk down another level if you have one, and you'll feel that it should get cooler and cooler as you go down. So here is a picture of different sources of radiation. So you have, or of different heat transfers. You have radiation, which is heat that comes off as electromagnetic waves. You then have conduction, which is the direct contact, and you have convection, which would be that water inside that's heating up and then circulating through. Now, water is interesting because it releases heat very slowly. It tends to hold on to its heat. It absorbs vast amounts of energy from the sun, but it releases the heat very slowly. oceans have an important role in helping moderate the Earth's temperature. What you notice is if you live over by the coast, you tend to have a temperature that doesn't fluctuate quite as much from hot to cold, because the water is going to hold onto that heat and kind of help maintain that temperature. So they have what we consider a mild climate when you're near the water. Energy from the sun. So here we have radiation, conduction, and convection are how you move energy from place to place. So in warm air, molecules are moving faster, they're more spread out, those molecules are spread out, it's less dense, and it tends to rise, and it carries more energy than cool air. Now cool air, the molecules are slower, and you can see it in the picture, they're blue, they're closer together, and the air is more dense, it tends to sink. Radiation, sunlight warms the ground. Conduction, the warm ground heats the air directly in contact with it. And then the convection would be the cool, dense air sinking downward and the warm air going up, and it creates that cycle of convection currents. So what we want you to get from this chapter is the three main types of energy transfer. So we have heat transfer in the form of radiation, in convection and conduction, and to understand how each one works.